Hello, this is Pie Snake in the Fog by Tulrak. Uh, it is another pie snake. We did a pie snake in the puzzle previously, and it was pretty cool. There was this one extra step that I did, but honestly, I still think the puzzle was a really good one. But now we are doing it with fog. So, pie snake. Okay. Let's look through the rules of this puzzle. So, normal Sudoku rules apply. So digits 1 to 9 in every row, every column, and every 3x3 box. The grid is partially covered in fog, which are these grey cells. So this is fog. Placing correct digits will clear the fog from surrounding cells. So let's say I placed like a 5, then it was right. Then the cells around it would all be opened up to reveal more of the puzzle. So I'm not going to place any digits down now, just in case I am lucky and place the right digit in here. Okay, but the pie snake rules are: color 25 orthogonally connected cells to create a 25 cell long, 1 cell wide snake. So any 25 orthogonally connected cells that do something like this. So your snake could look like that. That's fine. That's a cool snake. It has to be 25 cells long. It's not 25 cells long here, I don't think, but it has to be 25 cells long. It can only be 1 cell wide, and it cannot branch, so doing things like this is not allowed. It cannot touch itself orthogonally, so doing things like this is not allowed. So those are how you draw a snake. The starting digit is not given to us, interestingly, but the snake contains the first 25 digits of pi in the correct order, which is given here. This long 3.14159265358997238462643. Those are your first 25 digits of pi, and the snake must contain the first 25 digits of pi in that order. So what it says, it must be 3.1415, so on and so forth. Okay, so those are the rules of pie snake. Next we have the more normal quote-unquote stock rules. Digits in cells separated by a V sum to 5. You don't see any of those here. Digits separated by X sum to 10. So these two cells are separated by an X. These two cells must sum to 10. So wherever there is a 5, the two cells around it sum to 5. All given white dot. Oh, sorry. Digits separated by a white dot. Right. Digits separated by a white dot. Well, you don't see any here either. But if there was a white dot here, for example, then these two digits separated by it are consecutive, so it has to be one greater than the other. So it could be something like a 1 and then a 2 there. No negative constraints apply, so not all the possible such clues are given, meaning that two cells that sum to like 5 doesn't need to have a V beside it. Okay, all white dots and XV clues, which are what we've talked about just now, are fully on the snake. So if your snake did this, just drawing a random snake, then your X clue, well, is fully on the snake. So you cannot have an X clue take these two cells that are not on the snake. So I could make my snake look like this. This can't be where an X clue is. It can't be where a V is. It can't be where a dot is, basically, because it must be on the snake. So let's remove all the colors. Digits may not repeat on the negative diagonal. Whoa, okay, so we haven't seen that, but digits may not repeat on the negative diagonal, which is extending from the top left corner of the grid, which would be here, to the bottom right corner of the grid. So this long diagonal here cannot have repeated digits, and basically therefore have to contain the digits 1 to 9. Okay. It's called the negative diagonal, by the way, because the gradient of this line is -1, whereas the other diagonal is +1. Okay, and finally, digits in a cage, or the cage, because I guess there's only one of them, may not repeat and sum to the total given. So a cage consists of multiple cells linked together, so those could be a cage, and whatever the number is in the corner of the cage, these digits must add to it. So yeah, those are the rules. Those are a lot of rules, which you can't really see and visualize here. But over time, we'll see how it goes. With that, let us finally begin solving this puzzle with a monstrous rule set. I'm pretty happy to solve this one because I enjoyed the other pie snake puzzle, the one that was more vanilla-esque, that was only about the pie snake. So let's begin with this X clue over here. I think that's the only thing we can see right now. We know that all XV clues and the white dots are on the snake. So this must be on the snake, and your snake must therefore do this. Now that's interesting because these two cells are two consecutive, not consecutive, how do I say this? There are two digits beside each other on this like chain on this sequence of digits here that must sum to 10. And I'm pretty sure the reason why it's only this is because that is very limited. So from here, actually, we would need to find a set of two adjacent digits that sum to 10. And I'm wondering right now if I can actually find one. Yes, I can. Okay, so I think we're gonna look through this very, very slowly, but 3, 1 doesn't work, 1, 4 doesn't work, 4, 1 doesn't work, 1, 5 doesn't work. In fact, you can't have 5 on X at all because the other digit will be 5. So 5, 9 doesn't work, 9, 2 doesn't work, 2, 6 doesn't work, 6, 5 doesn't work, 5, 3 doesn't work, 3, 5 doesn't work, 5, 8 doesn't work, 8, 9 doesn't work, 9, 7 doesn't work, 7, 9 doesn't work, 9, 3 doesn't work, 3, 2 doesn't work, 2, 3 doesn't work, 3, 8 doesn't work, 8, 4 doesn't work, but 4, 6 here works, 6, 2 doesn't work, 2, 6 doesn't work, this 6, 4 also works, and 4, 3. So the only set that works is 6, 4 and 4, 6, which means that this is definitely a 4, 6 pair. Okay, so starting off very strong. Next is a secret regarding this pie snake that we figured out in the first puzzle, which is there exist a lot of these sort of palindromic-ish lines. So if you look at this over here, you'll see that this there are always these like 141, 535, 9793, 23, 626, which are actually just two of the same digit that are separated by this singular other digit. That is actually really interesting because how would you put that on the snake? We know that the same digit cannot be repeated here, and therefore it must cross a border somehow, right? Because if it didn't at all, if it just went in a straight line in any way, you would then repeat, definitely. So it must cross a border, but not only must it cross a border, it must do so diagonally, because it can't keep going after crossing a border. It clearly can't go, yeah, so however it works, it must cross a border diagonally, these palindromic sequences. So let's say if this was a 1, then your next 1, however it goes, in whatever direction it goes, it has to cross a border diagonally like so. And you can probably take the time to figure that out yourself and prove that. But that is very interesting because we've seen this 4, 6 pair, right? Wherever it's coming from, the 6 is actually part of the 6, 2, 6 sequence. And therefore, wherever the 6 is, must actually be able to cross a border diagonally. Which means that it can't be here, because this 6 is part of 6, 2, 6, and therefore the 6 here must cross a border diagonally. Which it can't, because nowhere does it cross a border. So the 6 is actually here, I think. Correct? Correct. And this is therefore a 4. Now, this 6 must cross a border, which means that one of these cells are a 6. This is an X clue, I think. You can tell, it's not a V clue. It's an X clue, which means it is on the snake. This is a white dot, which means that this is also on the snake. Now, I can't just go ahead and... Well, yes, well, I know now that... Well, I'm not entirely sure, am I? Because your snake could do something like this. Well, no, because it is another X clue. Yes, and the only other way to get an X is your second 4, 6 pair. So this is another 4, 6 pair. This can't be a 6, meaning that this is actually where the 6 goes. And then this is a 4. Nice, okay. So your 2 has to be one of those cells to figure out where the snake continues, but therefore your snake cannot go this way. So this is not snake. And I guess it could end like this maybe? No, your 4 goes to a 3. Although we don't actually know which of these is the end of the 4, because your snake could very well go something like this. That's fine. So this could be the end of the snake, this could be the end of the snake. It does not really matter which. Okay. Now that's pretty interesting too, because Yeah, this crop key dot is the next one that we're looking at. This white dot is called the crop key dot, by the way. It's not said here, but yeah, it's called a crop key dot. Its counterpart is a black dot, but we don't really need to know what that does right now. So where in this sequence do we find consecutive digits? 3, 1, 4, 1, 5, 9, 2, 6, 5 is one possibility. I'm gonna mark that down. We have 6, 5 as a possibility. 3, 5, 8, 9 is another possibility. 7, 9, 3, 2, 3. So 2, 3 is another possibility. 4, 6, 2, 6, 4, 3. Wow, 4, 3 is also a possibility. That is a lot of possibilities. Now, can we eliminate any of them maybe? But the fact that this 5, 6 has to be a 5, 6. Yeah, in fact, actually, this can't be a 6 or a 4. Right? Could it be a 2? I mean, yeah, it could be a 2 if that's a 2. Huh, okay. So these are the four possible things you could have on this crop key dot. That's somewhat interesting. Well, I mean, I guess we can then say, does this connect directly to this 4? Which I think it can be like 2, 3, and an 8. Right? Yeah, it could be 2, 3, 8. Yeah, so it's fine if it connects directly to 4. But I think in any other case... Oh, this can't be 3, 4. Right, because the 3, 4 has to be the very end. But we know that one of these 4s acts as the end already. So this can't be the end as well. Meaning that this can't be 3, 4. So we can remove that as an option. Now this is very likely for this to be a 2, 3 if it connects directly to this 4. If it was an 8, 9... Again, I guess it could always do this. Although, okay, no, the 2, 3 actually, the 3, 2, 3 is a border jump because it's a 3, 2, 3, which means that the 3 must have come from here, so it would have to be something like this. The 8, 9, and 6, 5 don't suffer the same problem though. Although I do in fact notice that the 5 is part of a border jump, and the 9 would also be part of the border jump. Because 9, 7, 9, and 5, 3, 5. Although I guess if that doesn't happen, if you could do this. I mean, there must be some way to prove that you can't do that. Like, suppose this was an 8, 9 pair. Right? How could you get from here? Because this can't connect directly to here anymore. Meaning it has to go away. How would you connect from here all the way to this 4? Yes, well, yeah, because... Well, I mean, could do this, couldn't it? So, I'm gonna remove those digits, see if I can place them here. Just gonna make this a 5, 6, 8, 9, 2, 3. So, you could have 8, 9, 7, 9 maybe. Or 8, 9, 7, 9. Yeah, so you could have something like this. That's how a border jump could be possible. 7, 9, 3, 2, 3. That doesn't feel very possible then. Okay. Not entirely sure where this is going either, actually. Yeah, I don't really see how to say this is impossible. Like, even if 8, 9 wasn't far enough ahead, couldn't we always make this a 3, 5? Oh, sorry, a 5, 6. And then we could say that, well, how do we make that work? It could be like a 6, 5, 3, 5. Although if this was not the 2, 3, then this must be either 5, 6, or 8, 9, which is in the middle. So this is in the middle of your snake, which means the snake must extend in both directions. So how would this extend how would this extend? Because it cannot directly connect to that, because we know, or we're assuming it's not 2, 3, it would have to extend outwards like that. Then this one cannot extend outwards, and therefore must extend in one of these directions. Which, okay, so we know 5, 6 contains a 5, which is part of the border jump. The 8, 9 contains a 9, which is part of the border jump. How would that border jump work? Could the border jumping digit be here? So could this be like a 5 or the 9? Well, it would only be able to border jump if it made this move, right? Because this can only jump diagonally in this direction. It can't do this or that, so it has to go there. But now how does this escape? Because we know it doesn't connect this like so. Does it? It would have to do this, right? Because 9... Yeah, after your 9, 7, 9, you need 3, 2, 3, and then another 8, which clearly cannot be done in these little cells. So what it would have to do is you have to leave like this. Well, I mean, firstly for the 9, 8, 9, that's already not possible because you have a 3, 2, 3 coming up, which clearly will repeat the 3 in here. The 5, 6, 5, the 5, 3, 5 also feels very wonky. Yeah, because after this, you can't go down this way. Otherwise you connect to this 4, which is too early. So what you would have to do is go this way. But then you have the 9, 7, 9 coming up after the 8. So 5, 3, 5, 8, 9, 7, 9. So it can't do that. Which means I'm pretty sure that it cannot extend both ways. In fact, it cannot extend this way at all. And therefore must extend down in one of those cells, right? Meaning this is 2, 3. Meaning this is 8. One of these are 8s. Right? I think so. So this is 2, this is 3? Ah, it is. Okay. Well, that's a deduction I'm happy with. Where can the 3 go now? The 3 cannot go this way. Yeah, because before the 2 is a 3. Can't be there. It could be one of those cells though, I think. Because your snake could do anything like this. But the snake does in fact go here. Which means that this is not the end of the snake, and therefore this is the end of the snake. Where can that end of the snake be? Can't be there. It could be one of those cells, but because we know one of these are 3s, that removes 3 from that cell. So 3 goes there. Right? Yes, it does. And is the end of the snake. Meaning that it cannot branch out anymore. So therefore this is not a 2. And therefore 2 goes there, which is part of the snake. This is not 8 because this cannot be part of the snake. It cannot touch itself. So 8 goes there. That's a part of the snake. That does release more fog. We can cover a lot of cells that are not snake anymore. So those cells are all not snake. This cell doesn't look like a snake either. I mean, it could be though, because it could always grow outwards like this. In fact, we must figure out what happens next. Yeah, okay, this cell can't be snake, because if it was, it would have to be a 3, because you have to do the start, which is 3. So this can't be snake. Actually, can this be snake? No, because after the 3 comes a 1, 4, 1. And this would then be a 1, which cannot border jump. So this can't be the start snake, which means it's not there. So one of these is a 3. Which actually can't be the start of the snake either, because that forces a 1 into one of those cells, which cannot border jump. So that's slightly interesting. So very interestingly, we're looking at the end of the snake here, rather than the beginning. Which means we're looking at this backwards. After the 3 comes a 9. Wow, okay, there are actually no clues here. What do we see? So none of these are snake, I think. I think we can very confidently say that. Actually, the 9 is part of a 979, right? Yeah, so if it went this way, could it go up here? If it went up there, it would have to border jump like that. And then it will kind of push itself in. And then it can't leave through here. So, even looking at the snake backwards, I don't think it can go this way. So it can't go there. Meaning that if it went up here, it would have to go here. And if it went down here, well, because none of these are snake, it would have to go here. So one of those cells is a 9, which is before the 3. Ah, and this actually can't be the 9 because we know 9 has to border jump. It's a 979. So it can't go this way. It has to go this way. So I think that's right. That's a 3 and that's a 9. Very cool. So those are snake. This 9 has to border jump, can only do so like that, so that's a 9. Meaning that one of these are 7. Oh, shh, you didn't see that. You did not see that. You did not see that. Nothing happened. No fog was cleared. One of these are 7s. Okay. That's not even the right color. Shh, you didn't see anything. In fact, actually we can prove that this is not a 7 because it can't go down this way. So that's just a 7, which in fact does clear the fog. Alright. That was a huge mistake on my part. I should have been a lot more careful, but we can prove that these are not snake. And in fact, this is not snake either. Okay, again, not a lot of clues to work with. I don't think that can be snake. I mean, if it did, we have to go this way, right? Yeah, again, none of these can be the start of the snake, because wherever it is, the one beside it would have to border jump, which it can't. So none of these can be start of snake. And none of these can be snake at all. Which means that, yeah, because none of these are 3s, none of these can be the start of the snake either. And wherever it enters here, yeah, because this must, if this was snake, it would have to be where the start is, right? You can't have a snake go in and then come out again. That's just not possible. So none of these are snake either. This is not snake because, yeah, actually none of these are snake because none of them are 3. And none of these are the start of snake, making them not snake at all. So those are not snake. Wow. Okay. Where does this go? Right, before the 979 is an 8. Okay, 8 is one of those cells. Oh, and this 8 sees that, so 8 doesn't go there, so that's an 8. Which is part of the snake. Right? Yes. And actually this 8 must now see a 535. Okay. So where does it go? Well, could it go this way? If this was a 5, how would it border jump? It actually cannot. Right, it must be a 535 which does border jump, but it can't jump this way. It can't jump this way either, because the only way to do that is to do this, causing the snake to touch itself. So that can't be a 5, meaning that this has to be a 5 is. 5 can't go this way, because this 5 here can't border jump, so this is 5. Which must border jump here. We can mark these two as snake cells, because all dots must be part of the snake. And this must border jump, it can't jump this way, but it could jump in any of those cells. I want to say this is possible if it did something like this. That would be a very goofy snake, but it could. Although, what could this pair be? We ruled out the 4-3 at the very end. We ruled out 2-3 over here. We ruled out 8-9 over here. So the last pair is 6-5, right? So this is 6-5, which means that this can't be 5, or it could be 5. But, no. This is, okay, so sorry. This is 565. And the 5 here must connect to this 5, because this 5 is part of the 535. This 5 is part of the 535. So the 5 here must connect to the 5 here via the 3, and therefore can only do it if the 5 is here. Yes, so I'm pretty confident that's a 5, that's a 6. This 5 means one of these are 3s, which we can't disambiguate yet. But that means that happens. This is no longer a 5. And so we can remove more snake cells. This clearly can't be snake because one of these is where the snake goes. So before the 6 comes a 2. So one of these are 2. And then before that comes a 9. This 2 doesn't work because if it goes this way, the next cell would be here, which would have to be a 9, but sees that 9. So this can't be snake, meaning that this is snake. Therefore this is not snake, and therefore that is snake. Meaning that is 3, that is 2. This 2 must see a 9 this way because it can't go this way, otherwise the 9 would see those cells. So those are non-snake, that is snake. This is therefore a 9. Wow, actually we haven't even seen the killer cage yet. Where is it? Whatever it is. The 9 sees a 5, so it can't go up here. Meaning one of these are a 5. Oh, that's interesting, because after the 5 comes a 141, which must border jump. So this can't be a 5, right? Because this 5, wherever you put the next one, you can't even put it there. And the one over here would not be able to border jump. So this can't be a 5. So this would be a 5. And then the one after that must border jump, so the only way you can put a 1 from the 5 would have to be up here, I think. Cool. Which has to border jump. And cannot border jump this way because it must be part of the snake. So the 1 goes there. And therefore by the V clue that's a 4, which is also part of the snake. Because we know that the snake has this entire thing. And the last digit is a 3 before the 1, and this can't be the thing. Oh my goodness. This can't be snake. So it has to go up here. So that is snake. Which is 3. And there you go. That is your snake. Wow, okay, we got this snake way faster actually. That is our snake. So cool. Nice, okay. 3414 1592 6535 8979 323 84 62643. And just to check, 3 6 9 13 16 17 22 27 24 25. Yes, 25 digits. Okay, so that's our snake. What a lovely snake. Okay, time to do just regular Sudoku now. Actually, you know what I should do? I should draw the snake with a line instead of coloring, because I think that's a lot easier. Yeah, that's a lot easier to see. And then all the colors we can remove, which allows us to see the fog way better. So that's our snake. What a cool looking snake. Alright, let's do some Sudoku. Shall we? Where does 3 go? Anywhere. Nah, we can't figure out where the 3 goes anywhere. No, 3 can go anywhere. Yeah, 3 can go anywhere. What about 6 in this box? These 6s see all of those cells, so 6 goes there. Meaning that these cells are 147. Actually 14 here sees that, so that's a 7. This can't be a 4, so that's a 1, that's a 4. Cool. What are those cells? Those are 8 and 9. This 9 sees that, so that's 8, that's 9. These cells are 157. This 1 sees both of those cells, so that's a 1. This is a 5-7 pair. These cells are therefore 2 and 9. 9 again sees that, so that's 2. That's 9. Those cells are 5, 6, 7, which we can't disambiguate yet. Wow, okay. Very tempting to try, but no, I guess not. Oh, I love this music. Whoa. Is this Pokemon? I think this is Pokemon. Ha, Pokemon. Anyway, where was I? Right. 3 is in one of those cells. 4 actually is in one of those cells. And 6 is in one of those cells. So this is actually a 3, 4, 6 pair triple. Where that is not a 3. Oh, I apologize for that. Therefore, in this box, 8. No, sorry. I thought I was onto something. I was not, in fact, onto something. Although I guess this 1 and 9 are not in those cells, so 1 and 9 reside there. But that doesn't really help, does it? No, it doesn't. We know 1 and 9 are there, but we can't say exactly where. So unfortunately not gonna be helpful. Am I gonna be stuck on this because of Sudoku again? Like, you know, like when I solved the original, well, the newest pi snake not equal to 4, I got stuck because of basic Sudoku for so long. Actually, what are those cells? I should look at that. These are 2, 7, 8. And 7 come in those cells, so 7 goes there. These are 2, 8. What are those cells? I mean, 5 is one of those cells. 6 is one of those cells, but what else can we say? Not exactly anything much. I mean, what are these again? 1, 4, 5, 6? Yeah, 1, 4, 5, 6. And these can be 5, these can be 6. That's a really small thing to do, but I suppose it could help. And these are 1, 4, 6, 1, 3, 4, 6. Yeah, 1, 3, 4, 6, but can't be 6. Look at that. This one sees that, so that's 3 or 4. Okay, that's somewhat useful, maybe. Okay, not saying this. Any other clues that I've not been seeing? I mean, maybe I look at the diagonal now. 4 can't be there. This 4 means that can't be 4. So 4 is in one of those cells. Does that help? No. Because 4 is in one of those cells, but that really is not an X-wing that we're looking for. So we can't do that. What else do we have? Actually, what is that? That is pretty... Yeah, it can't be 1, it can't be 2, it can't be 3. It could be 4, it could be 5, it can't be 6, 7, 8, or 9. So this is a 4 or 5, right? I guess so. This 3, 4, 6 means that... Well, we know 3 and 6 are not in the cell. We know 4 is already not there anyway. So that doesn't help. This can't be 1 or 9. Well, I guess 1 or 9 are already on here though. What are these actually? Are these 2, 4, 5, 8? Yeah, this can't be 4. This can't be 5. And then this could be anything, I think. There's a cage somewhere? Where's the cage? I don't see the cage. Okay. So 9 is in one of those cells. Yes, in fact, where does 9 go in this box? That really helps because 9, these 9 see those cells. This 9 sees that in the diagonal, so that's a 9. Which, if done correctly, should reveal... Yep. Oh, 38. That is a huge cage. Wait, is 38... 38 could be... Oh, 38 goes there. Alright, well, let's see. Digits in the cage may not repeat, and sum to the total given. So, assuming... Well, I don't know how long a cage must be, actually. But, let's think about it. If you had the digits 1 to 9 and sum them all up together, what would you get? You would get 45. And 38 is actually only 7 less than that. So whatever digits you exclude from the 38 cage must sum to 7. The issue is it could be done in 3 cells. So you could technically have a 6 cell cage. So your cage could just look like this. But that means your cage is at least 6 cells large. And because none of these are caged, I think we can sort of say that your cage has to be like this. And I guess right now we can color in the cage. So this is the 38 cage at least. It could grow out here, it could do more. But the 38 cage must at least occupy those cells. Yes. Okay. Well, let's think about what would happen if this was only 6 cells. Actually, that would do a lot of things, because if it was only 6 cells, then the cells it excludes must sum to 7 in 3 more cells, which are definitely 1, 2, and 4. Right, which means that none of these can be 1, 2, or 4, which does very handily place digits down here. This has to be 6, 8, 5, this Has to be a 2. This is a 1-4 pair. But is that possible? These cells now have to be 1, 2, and 4. Which I guess is possible because, you know, this could be a 4, this could be a 2, this could be a 1. But I think it looks like it's fine if it's 6 cells. If it's 7 cells, I think that we have more options. If it's 8 cells though, then we are only missing a 7. Seven is one of these cells. Actually, 7 is one of these cells. Now, okay, I think we can do something with this. If this cell was 8 large, it would have to extend to here. That would have to be part of the cell. It can't do this because then these are summed to 38. This would then have to be 7, which isn't possible. So the only way to make your 8 cell cage is to go down. Ah, and that fails. Because because even if this was an 8 cage, the 8 cell cage cannot have a 7 in it. None of these cells are 7, and therefore where does 7 go in box 1? It has nowhere to go. So it in fact cannot be an 8 cell cage, and therefore it's either 6 or 7 cells. Okay. Now if it was a 7 cell cage, that is a lot more complicated, because what could it be missing? Is this cage valid? No, this thing doesn't let you... Oh, right, because again, I don't know if it's 5 or 6 cells. So if it's under the 4, you can't actually tell how many cells it is, and therefore the cage doesn't give you the possible combinations. Well, I'm saying if it's 7 cells large, what is it missing? It's missing either a 2-5, 3-4, or 1-6, right? Oh, and therefore in here, that's pretty interesting because it can't be 1-6. Because you don't have a 1 of those cells. It can't be 2-5 because this is neither 2 nor 5. And therefore it must be 3-4, which has to be 4 here, 3 there. Yeah. So, okay. So if it was 7 cells, this is 3 here and 4 there. Now what if it was 6 cells? Then again, we would know that this is your 1, 2, 4. This would not be 1, 2, 4. This would be your 6, 8, 5. And then these cells would be 1, 2, 4. Ah, yes. If it was 7 cells, we know that this is a 3, this is a 4. If this was 6 cells, we know this is 1, 2, 4. But that's actually also pretty forced, because this can't be 1 or 2. So therefore it is a 4. So this can't be a 1, so that's therefore a 2. That is a 1. Meaning that scrapping all this, we have only 2 options. Either, I'm going to take my smaller pencil mark, this is a 3, this is a 4. Or, this is a 4, this is a 1, this is a 2. Which means that we are slightly better off with our possible digits in these 2 cells. Oh, right, okay. And these ones actually see those cells. So one's in one of those cells, which does form something of an X-wing. One is in one of those cells, and one's in one of those cells. In these 2 rows, there must be only 2 ones, one for each row. One of them is here, and one of them is here. Therefore, nowhere else in these 2 rows can there exist a 1. There can't be a 1 here, and therefore 1 is in one of those cells. Which means that, actually, the 6 cell option isn't possible. Because in the 6 cell option, this is a 4, this is a 2, this is a 1. But we already know that's not possible. So, the 6 cell option isn't possible, and therefore must be 7 cells. Which therefore means that this is a 3, and that is a 4. Boom, okay. Logicked. Get logicked. Now these are 4. Oh, sorry, now these are 4. Wow, that is some logic indeed. Okay, this 4 means that's a 5. That can't be 4, that can't be 5. This 5 means that's no longer a 5. And we basically have everything done here. There can't be any X or V's or dots here because the X and V's and dots must be part of the snake. So this is basically just regular Sudoku now. Yeah, whatever digits I place here will always come to 38 because the outsides are handled already. Which means it is actually legitimately normal Sudoku, I think, besides this 2-8 pair here. Cool. These are 2, 5, 7, 8. Yes, okay, when does 5 go in this column? These 2 5s see those cells, this 5 sees that. These are non-5, so 5 goes there, 7 goes there. Okay, 5 in this box is in one of those cells. Sevens? Not really. Seven is in one of those cells actually. So in this box, 7 is in one of those cells. In fact, this is actually just a 278, right? This is a 278 triple. So what are these? These are 159. And this can't be 105, so this is a 9. This is 105, removing 1 as an option from there. Forms a 3-4 pair, so this can't be a 4, meaning in this box 4 can only go there. That is correct. There's a 1-6 pair, means that's a 5. Okay, this 4 means that's a 6. That's a 4. This 6 means that's a 1, which is correct. Okay, that's a 6. One of these is a 1, but the 1 here sees that. So 1 goes there. Very nice. These cells are 189. Oopsies. Wrong tab. 189. That can't be 1 or 9 actually, so that's 8. This is not 8. Oh, this 1-5 pair actually also sees this cell, so that's not a 1, that's a 9, that's a 1. This 8 means that's not an 8. This 2 means that's not a 2. Oh wow, chocolate teapot. Fancy. This is either a 7 or 8 as well. 8 in the row. This is 3, 2, 4, 7. 2, 3, 4, 7. This can be 3 or 4. This can be 2. Nothing of interest. 6. 6 in one of those cells. 4 is in one of those cells, I guess. Oh, no, 4 is in one of those cells as well. We already knew that. 3 is in one of those cells. 3 here. 3. 3 could be there if we wanted it to be. Oh, actually, in this box, where does 3 go? Yeah, this 3 sees that. This 3 sees that. So 3 goes there. Therefore, this is no longer a 3. In this box, where does 3 go? 3 can't be those cells. Those can't be 3. Yeah, because of this 3, those can't be 3. So 3 goes there. This makes this a 4. That's a 3. This is a... Actually, this is a 2-7 pair. So that's no longer 7. That's a 4. This is either 6 or 7 by the column. And because of this 7 means that's a 6. That's a 7. This 5 sees that. So that's a 6. That's a 5. This is 2, 7, 8 still, right? And this can't be 7, so it's another 2, 8. Is this another chocolate teapot? What? Okay, I guess we're gonna resolve it by this cell then. Yeah, I guess so. Otherwise, you know, this is actually a deadly triple. I was gonna say deadly pair. That's a deadly triple. This is therefore a 6 because in the column, these are 2, 7, 8 again. Wow. Okay. This 7 sees that. So actually 7 in this box has to be there. This is no longer a 7, so 7 in this box goes here. These are 1, 2, and 8. This 2 sees that. The 8 sees that. Another one of these guys. This is now a 5, I think. Yes, in the row. And this is 2, 8, 9. And 9 sees that. 8 actually sees that as well. So that's a 2. This is an 8. This is a 9. This 2 means that's a 1. That's an 8. This 1 means that's a 5. That's a 1. And this 8 means that's a 2. That's an 8. That's a 2. This 8 sees that from very far away. So that's a 2. Which resolves this chocolate teapot. Which resolves this chocolate teapot. This can be a 7. So that's a 2. That's an 8. And that is a 7. Solving the puzzle. Well, that was really cool. I enjoyed that a lot as well. Definitely a lot of interesting logic. I wonder if the killer cage logic over here was what they intended. It definitely felt like a much more different part of the puzzle than just figuring out what the snake was. But I have the snake here. Otherwise, it is actually a pretty cool puzzle. I could make this like a series as well, because I think Tulrak has a third one that was actually made, I think, way earlier. Yeah, but this was actually a really fun puzzle. So yes, I'm really glad I get to play it. Yeah, I hope you enjoyed watching it too. I will see you now. Bye bye.